Good day, favorites. Welcome back to another episode of our favorite tutor, and today we'll be talking about scalar and vector. This will be nice. Okay, physical quantities can be grouped into scalar quantities and vector quantities. The scalar quantities are quantities that have magnitude only, just magnitude. For example, time, length, distance, speed, and so on and so on. While the vector quantities are quantities that have magnitude and direction. For example, your displacement, your velocity, acceleration, force, weight, and so on and so on. There are many. So we'll just focus on the vector quantities, because the scalar quantities, whenever we have multiple scalar quantities, they can be added or subtracted algebraically. While the vector quantities, it has its own what? Techniques. Okay, for vector quantities, a vector quantity can be represented by a straight line with an arrow. Now, this line, the line represents the what? The size of the vector quantity. The line represents the what? The size of the vector quantity. While the arrow represents the what? The direction. Indicating that this is a what? A vector quantity. It has what? Magnitude, which is the what? The line, and what? Direction, which is the what? The arrow. A vector quantity. So we are going to take cases of multiple what? Vector quantity. When we have multiple vector quantity. For example, when two forces act on a body in the same direction, that's the first case. When two forces act on a body, for instance, this is the body, two forces acting on this body. So there's a block. Now this is the first force, force 1. While this is the second force, force what? 2. Acting on this body. The net force on this body is the sum of what? Force 1 and what? Force 2. So therefore, the net force, which is the resultant, is equal to what? Force 1 plus what? Force 2. For example, if this force, let us say this one is what? Let's say 6 Newton, while this is what? 8 Newton. So therefore, for us to get the what? The resultant, or the total force, or the net force acting on this body is going to be what? 6 Newton plus what? 8 Newton, which is equals to 14 Newton. So the force acting on this body is what? 14 Newton. Now this is the first case. Second case, when forces are acting on a body in opposite direction. This is what? Force 1. Where this is what? Force 2. Let's say this is, let us call here 4 Newton. And let us go here 8 Newton. Now, what is the force acting on this body? But before then, this is the force, 4 Newton, acting on this side. Here's the what? This side is the west. Why here's the what? The east. That's the direction. Now, where will this body move to? Let us say this is the block. Where will the body move to? The body will move to the east. Because the forces on the east is greater than the force on the what? West. The body will therefore move to the what? East. Now, what is the net force on this body? Which amount of force is acting on this body? The net force on this body is the what? The subtraction of these two. That is the resultant, that the forces that is acting on this body is equals to what? 8 Newton minus what? 4 Newton, which is equals to what? 4 Newton. And that's so. For instance, let us say, okay, let me use me and you for example. All right, you are here. You are dragging this body to this side, and you are aiding what? 4 Newton force. While me, the strongest person here now, I'm on this side, and I'm aiding what? 8 Newton force. Of course, I'm going to pull you along the what? With the body, with the block. For me to move this block, I'll first of all overcome this guy here, which is you. First of all, overcome this guy here, because this is acting as what? Frictional what? Force, opposing motion. Now, for me to overcome this guy, I need to give out what? Some of my forces will be what? Given to you right here. So therefore, if I subtract 4 Newton of force from my force right here, if I subtract 4, so here will be round up to what? 0. While the remaining force, it will not be what? Acted on this what? Block. So the block will what? Move due to what? The action of what? 4 Newton of what? Force. What moved the block is the force of what? 4 Newton. Because I need to overcome this word force, which is the frictional force, opposing what? Motion. So therefore, the block is going to move to the what? To the east with what? 4 Newton what? Force, which is the what? The total force acting on the what? Body. Now, this is the first case, this is the what? The second case. All right, third case. When the forces are what? Perpendicular to each other. When the forces are perpendicular to each other, that means they form what? A right angle. That is angle of what? 90 degrees. Let us say here is what? 3 Newton. And let us say here is what? 4 Newton. Now, what's the resultant? The resultant is going to be, all right, this is the resultant. This is the resultant. When forces are acting perpendicular to each other, if here is 4, this other side will be what? 4 Newton, and here will be what? 3. Because opposite side are what? Equal. So therefore, we have an angle of what? 90 degree. 90 degree. So for we to get the resultant, this resultant right here, if I bring out one side of it up, so I'm going to have something like this. I'm going to have something like this. So I bring out this side out. Here's what? 3 Newton. But here's what? 4 Newton. And this is what? A right angle triangle. Now the resultant, for me to get the resultant, we use what? Pythagoras what? Theorem. So the resultant is equals to what? 3 Newton plus what? 4 Newton. That's a 3 raised to the power of 2 plus what? 4 raised to the power of 2. So this is the resultant. Is equals to what? 9 plus what? 16. So therefore, we have what? 25. And the resultant is equals to what? 5 Newton. Okay, now for we to get the direction that is, we are looking for the what? The angle, either theta or what? Alpha. For me to get the direction, we use what? Tan. That's for this. Tan. For direction, let me put it here. For direction, we are going to use what? That means we are looking for what? Alpha, which is the angle. It's going to be what? Tan alpha equals to 3 over what? 4. So therefore, alpha is equals to tan inverse 3 over what? 4. So alpha is equals to 40.9, let's say approximately 40.97 degree. So this is the what? Direction. Just like you are looking for direction, you have the opposite, you have the adjacent. Is what? Tan. So that's for what? Vectors when they are what? Perpendicular towards each other, creating what? Angle 90. Okay. The next one we need to look at is when two vectors acting, okay? Let us say when we have what? An angle of what? Angle acute or what? Obtuse. That is two vectors forming an angle that is acute or what? Obtuse. For acute angle, that is something like this. Say something like this. Acute angle, I mean angle that are greater than 0 but less than what? 90. While obtuse angle, I mean angle that are greater than 90 but less than 180. So this is an acute angle because it's not up to what? 90 degree. This is 90 degree when it's perpendicular to each other. So acute, therefore, it's not up to what? 90 degree. While what? Obtuse, for obtuse, something that is what? Above 90 but not what? But less than what? 180. So this is what? Obtuse. Now for this, for we to get the resultant, we use what? Cosine rule, or what we know as what? Parallelogram law of what? Vector. We use the cosine rule. So I'm going to explain it. Let me clean this side of the board. For instance, we have vector forces acting, let's say 60 degree to each other. Okay, so if like this, if this is what? 90 degrees, 60 degrees should be well, like this. Am I right? Okay, let's assume that this is what? 60 degree. 60 degree. 60 degree. And let's say right here, the force is acting right here is what? 15 Newton. And the force is acting right here is what? 25 Newton. So we are looking for what? The resultant. Now, what is the resultant? All right, this is the resultant. The resultant. So, now let us illustrate this thing better. This is the resultant. So therefore, if here is what? 25, right here will be what? 25. 25 Newton. All right, right here is going to be 15 Newton. That means they are parallel to each other, the same what? Magnitude. So therefore, for we to get this what? Resultant, let me bring it out. That's one side out with the diagonal. So you have something like this. Something like this. So this is what the resultant. Right, this is an angle, which is what? Unknown. Unknown. Let's call this what? Alpha. Y right here is what? 25 Newton. Y right here is what? 15 Newton. Now for triangle, it's a triangle. For triangle that are not right angle triangle, 90 degree, either we use what? We use the what? The cosine rule. We are looking for what? The resultant. The resultant. So therefore we use the what? The cosine rule. Cosine rule, which says that what? A square is equal to what? B square plus what? C square minus 2bc cos theta. And don't forget, theta should be equals to what? 180 Note that theta is equal to 180 minus what? Minus alpha, minus the given angle. How is that true? Because if we are looking for what? We are looking for the resultant, the angle that is facing the resultant. The angle that is facing the resultant, which is what? Theta. And the angle that is facing the resultant. If right here, from this one, let's use this sketch. If right here we have what 60 degree, if I elongate this the more, there is alternate, this what alternate angle. We also have what 60 degree right here. An angle on a straight line is what 180. So therefore, how do we get 180 right here? How do we get this angle facing the resultant? It's going to be what 180 minus what 60. So therefore, we have it here, which is what 120. Because 120 plus what 60 is what 180. So the angle right here is what 120 facing the what the resultant. So therefore, to get the resultant raised to the power of 2, which taking the part of A, is equal to what 15 raised to the power of 2 plus what 25 raised to the power of 2 minus what 2 times what 15 times 25 cos 120 degree. So we move further. A is equals to 15 raised to the power of 2. 15 raised to the power of 2 will give us what? 225 plus 25 raised to the power of 2. I think we have 600 and what? 25 minus, okay, let me say 2 brackets. 15 times what? 25, that's 375. Cos 120. Cos 120 is minus 0.5. Minus 0.5, the same thing as, let's say, minus 1 over what? 2. Minus 1 over 2. Okay, so therefore I can say 2 is going to cancel out 2 here. Leaving what? Minus. So this is the same thing as what? 225 plus what? 625. This is 850 minus bracket 375 times minus 1. We have what? Minus 300 and what? 75. Yes, of course. Bring this side. So therefore, when negative sign multiply each other, we have what? Positive. So the resultant is equals to 850 plus what? 300 and what? 75, which is the resultant is equals to the square root of 122 what? 5. Why this is equals to what? 35 what? Newton. Ladies and gentlemen, this is the answer to the question. This is the resultant of the words, the vector. Now, please take note of this. I want you guys to take note. First case that we discussed, we just discussed what? 4 cases. The first case, vector acting in the same direction. We do what? We add. While vector acting in what? Opposite direction. We do what? We subtract. We subtract the smaller one from the what? The bigger one. While vectors that are what? Perpendicular to each other, we use the what? Pythagoras theorem to get the resultant. And for vectors that are what? Acute and or obtuse, we use the what? The cosine rule to get the resultant. And to get the direction, which is what? Alpha. To get the direction, which is alpha, we use what? The sine rule. Ladies and gentlemen, that brings us to the end of this what? Episode. Please stay tuned for more. More are coming. Just stay tuned and don't forget to subscribe to the channel. And please share the video. I want you to share this video so that I can reach out to many students out there. I remain your favorite tutor. Thank you and God bless you.